The LeetCode problem we are going to solve now is called +1. We can see that this one is a LeetCode easy problem and also a very well-liked problem. Basically, we are given a large integer that is being represented in an array sense and represented as digits, where every single value inside the digit represents that particular position. So now we need to just simply add 1 to this given array and return the new value in the form of the array. So without reading all of this, let's just try to understand it normally. Let's say that we are given an input. Basically, originally we are supposed to be given value 9523, but this is given in the form of an array. Now we need to do +1, so basically this value would become 9524, and this we need to return as the array. So we are going to once again going to create an array and we are going to return 9524, and this is the answer that we will have to return. Same way, if these are the digits we are given, we are simply going to return 1002, but in the form of an array. Now the thing is, when we are dealing with any value that contains 9, then we will have to work about the carry because we are adding one value to it. So if this is the value, we know adding 1 would yield the value as 10000. So once again, this is also going to be the array that we are going to have to return. But now notice that because these were all 4 nines, this was a 4-digit character, but this became 5-digit answer. So we will have to return an array with 5 entries, and this is the only edge case where we'll have to do something. Now logically, if you are ever going to be presented with this question, you are simply going to use the most basic math of addition and subtraction. So you are going to take whatever the value that we are given, that let's say that we are given value 1 2 3, you are going to start traversing from right to left, and in this fashion first you will take the value. If this value is not 9, then we can simply just add one value to it and return the answer. So in this case, since this 3 is not 9, so we can make it as 4 and then return the array as it is. So we are only changing the one index value. Let's say that we are given a value something like 1 2 and 9. Now in this case, we know that this is a value 9. The moment we identify that there is a 9, we are going to change this to 0, and we are going to have to add 1 to this particular value and keep on repeating the same process. So basically in this case, we would have considered this to become 0, and now for this remaining portion 1 and 2, we can once again repeat the same operation, that we will have to add one value to it. So in this case, for this 1 and 2, this is going to be added with one more value, and since this is not 9, so basically we are going to mark this value as 3 and then return the answer as it is. Now the only problem is, if we identify for some reason that all the given characters are 9, then in this case what is going to happen? First we will try to add 1 over here. So then basically this would become 0 because this was 9. So we will have a value like this, where currently this is 9, this is 9 and this is 0, but this 9 also has value 1 that we will have to carry over. After the same operation, once again this would become 0, this would become 0, and we would have one carryover above this 9. Once again in the next iteration, all of these 3 would have become 0. All of these 3 would have become 0, and we would still have one more carry that we are going to add in a newly created value. So the simple algorithm that we can create is that we will start iterating starting from right to left. If we identify that value does not contain 9, we simply do +1 and return the array as it is. For some reason, if we find that the value does contain 9, we are simply going to mark that index position as 0, and once again repeat the same operation for the remainder of the array of adding value 1, and keep on repeating the same process. For some reason we go through the entire array and we identify that we are at the end of the loop, then we simply need to create one more array that is going to be the one size greater than the previous digits array that we were given, and we are going to initialize first value as 1 and all the other values as 0 and return that as the answer. So this is the whole solution. Now this is not any data structure or any problem that we are using. So it is going to run in big of one constant time time complexity, sorry, constant space complexity. Now in terms of time complexity, this is going to be dependent on the total number of digits that are present. So this is still going to be big of n, but it's not that much. It's a very simple problem. And now let's quickly see the coding solution for this one. So the coding solution is quite straightforward. All we need to do is just iterate over all the digits from left to right, and we are going to have a for loop to do exactly that. And then we are going to check that if the given digit is less than 9, we can simply increment the digit and return the digits array as it is. If that is not the case, if it is 9, then we will have to turn it to 0 and repeat the same process for subsequent digits, moving from right to left fashion. Now, in case if all the digits were 9 that we find out, then we simply need to have a new array called new digits that is going to be one character longer or one array space longer than the original digits array that we were given. And we are going to mark that value as 1 because that is going to be the most significant bit, and all the other ones are going to be 0 by default. And then we can simply return the new digits array. So this is the whole solution. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs beautifully, beats 100% of all these solutions. That is because it's a very simple problem. The coding solution is present in our GitHub repository, so feel free to go ahead and check it out from there. Thank you.